All right, you guys, thank y'all for coming to class. I like seeing my regulars. Uh, Today we're gonna get into, I'm gonna start off with story time. I'm gonna walk you down the road to where I'm trying to get. Please let me know if you're like, I don't get it. It's okay. I have to explain though why sometimes we do what we do in terms of verbalizing certain things. My intent is to make it easier to see, but sometimes we got to work through those initial bumps to kind of smooth it out and make it smooth. Okay. So first thing before I get into this analogy today is your exam is moving back. I sent an email and I'll update the syllabus. We have an extra week. Because again, the second test is the most important. All of the major motions of the body. Before we get into muscles that influence motion, we kind of have to have these motions, and especially the illusions. We've got to have a good understanding of developed understanding of these things. Okay. Sometimes it's hard to predict how the semester is going to shape out with the exam, so I do my best. But again, living document, adapt, improvise, overcome. Let's get to the lesson of the day, and that is Unit 1. We talked about how, in terms of motion, we need to be able to account for small piece moving about big piece and big piece moving about small piece, and the motions have to be the same if they get to the same place. If they start in the same place and they finish in the same place, those two motions have to be called the same thing, regardless of how they move globally. They move the same locally. So far, so good. Now, that is easier to assess when the motions are in one or two dimensions. What I mean by that is one dimension, sagittal, right? One dimension, I get to the same place, one dimension. Sometimes it can even be easy in two dimensions as long as those two dimensions are general. What I mean by that is if this was a board on a game and this was a piece on the board, I get to the same place whether I go up 2 spots first and across 2 spots next, versus across 2 spots first and then up 2 spots next. I get to the same place. Transverse plane throws a big wrench into that. Having motion in 3 dimensions makes things a little bit more complicated. And I'm going to give you examples why, and hopefully when you see the problem, you're going to understand our solution to it. Having joints such as the shoulder and the hip, our cervical and our trunk, be able to move in 3 dimensions means that the sequence of motion is very important. What happened first? What happened second? What happened third? So here we have our 2 dimensions, but now we have a 3rd dimension of spin. So in other words, let's say my player transverse, he did that first. Well, when he went forward, he'd be in a totally different place than if he went forward first and then spun. Rotation creates a new problem. We have a solution for it, but it creates a new problem. So imagine Ken, we know that his whole body can spin in frontal, sagittal, and transverse, right? Sequence is very important to make sure we get to the same place. In other words, if Ken goes sagittal first, then transverse to the left, this is his new position. But if he goes transverse first and then sagittal, he's in a different place. So to remedy this, a 3-dimensional joint such as the hip, shoulder, sequence matters. So what we know is, we know that the hip is made up of a ball and a socket, right? We are going to give the perspective of rotation, transverse plane motion. We're going to give that perspective to the long bone of the articulation. In this case, the femur. Campbell, what does that even mean? Let me show you what that means. internal and external, no problem. Femur's transverse and pelvis is transverse. But you know I'm rotating also when I do this. My femur is doing the exact same spin, right? Don't worry about my knee, just not very flexible. This is still internal and external, right? Because my femur is literally doing the same thing. But now I'm not in my pelvis's transverse plane. Now I'm in the pelvis's frontal plane. So that creates a conflict of articulating interest. Whose perspective is that internal and external rotation? I'm not going to call this ab and adduction, especially if my leg is straight. It's still rotation. That makes sense? So for the hip, internal and external rotation is going to be from the long bone's perspective, from the femur's perspective. And that way we can still see how this would be external, internal rotation. This would be internal and external rotation. For your shoulder, external, internal. This is still external, internal. This is still external, internal. Like my humerus is doing the exact same thing. And it didn't matter that it was in my socket's different planes because the perspective is from the long bone. It's literally rotating about the long axis of the long bone. Think of it like this. Think of it as for three-dimensional joints, like ball and sockets. We have to give ownership between the relationship, because remember, it's a marriage between articulation of bones. The femur is a separate bone in the socket than the ilium, ischium, and pubis. And it's almost like we're doing a prenup for the arrangement of this marriage. We're saying, okay, humerus, femur, you own transverse plane perspective. You own the perspective of internal and external rotation. And socket's like, okay, what do I get? It's like, socket, you get sagittal and frontal. You get flexion and extension, and lateral flexion and extension, ab and adduction. And I'll explain why. You have to do it that way with three-dimensional motion, or again, you'll do similar motions, but won't be in the same place depending on the sequence you do them. So because we're giving the socket, the sagittal, and the frontal, that allows us to do stuff like this. Flexion, external rotation. This is my new position. Okay. But if I did external rotation first, and I did flexion from the perspective of my femur, I'd be out here. Think about it. If you see flexion as the front of the femur going forward, there's the front of the femur. But we know this isn't flexion. Does that make sense? So it allows us to say flexion, external rotation gets me to the same place as external rotation and flexion. Does that make sense? It allows us, because we did the sequence, and we say rotation is from the long bone, and the general motion is from the socket, it allows us to get to the same places. I'll do it one more time. If we didn't have these rules, you would say flexion is the anterior. My bicep goes forward. Well, what happens if I externally rotate first? Is this flexion? Well, what I can say is external rotation and abduction gets me to the same place as abduction and external rotation. Flexion and internal rotation gets me to the same place as internal rotation and flexion. Sequence. Flexion and external rotation gets me to the same place as external rotation and flexion. If I didn't separate the perspectives, then I would be like external rotation and flexion, and I'm not in the same place. So let's revisit the knee. The knee also rotated, right? Not a lot, but it had significant rotation. Here's my polar axis, my transverse plane from my tibia's perspective. When I do this, this is where the rotation is happening in the transverse plane of the tibia, not the femur, because for the femur to rotate in its transverse plane, I would literally have to dislocate the knee. Does that make sense? So stick with me. Trust me. We'll do some examples of what I'm trying to get at. If I do something like this, we did this last class, but I want to explain it. If I did something like this, I could see how it would be confusing for some students because you're like, well, joint motion is relative to the joint, but the socket is frontal and the ball is transverse. So who do I pick? Do I say it's internal and external? Or do I say it's ab and ad? You see what I'm getting at? Do you see the issue? And that's what this lecture I'm trying to clarify. You say internal and external because the long bone owns the pure rotation. The socket owns the genital, the sagittal, and the frontal. And that's going to get into motions that you guys have probably heard before. Horizontal ab and horizontal ad. That's a socket perspective. That's a pelvis perspective. But the internal and external is owned. So in other words, the long bone is here, my femur is here, and I'm in the femur's transverse plane. Even though I'm not in the socket's transverse plane, I am in the hip's transverse plane when I do internal and external rotation. See what I'm saying? Do you see how this is the exact same thing as this? Those are the same spins, so we have to call them the same things. This is hip flexion. This is also hip flexion. Even though my hip is externally rotated, hip flexion gets me to the same place as hip flexion and then externally rotated. It gets me to the same point. Abducted, externally rotated. Gets me to the same place as externally rotated and abducted. That's what I'm trying to get at. That's why we have to do the way we do, so that we can get to the same place. All right, let's try to practice. Yeah. Well, the motion, so the question is, what's the difference between rotated and rotation? So the actual motion is the flexion. The actual motion is the rotation, right? So I would have left hip flexion, change in position. Left hip external rotation, the change in position. But my left hip is now flexed. My left hip is now externally rotated. So it's all in how you reference it. The actual motion is the flexion, external rotation. The position that it's at, my hip is now flexed. My hip is now externally rotated. That is relative to anatomical position. Great question. Anything else before we start to get into some examples?
So, on the last class, you were saying, like, you were laying down that the hip is sort of the opposite of moving the legs down, like your legs are out like this, your arms are still into them. Is that when you're laying down, like what examples?
But this, let's do one where I'm sitting down, and I will do one where I'm standing up. It's not dun, 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 dun. It looks different, but it's not. Globally, it looks different, whether I'm laying down, standing up, sitting down. But from the hip, it's like I'm doing the same thing in all three. So I just want to clarify that it looks different, but it's really not. I'm going to give you 3 examples: the laying down, the sitting down, and the standing up. Sitting down. Most students, not your fault, are taught to look at certain landmarks. So if you see this when I'm standing, you may say, oh, internal rotation is foot come in. It can be, but when I flex my knee, my foot can come in because I externally rotated my hip. Does everybody understand? Does everybody see? Do you see the temptation? It's like kinesiology, temptation island. External rotation. Okay? So if this is external, this would be internal. Good. If I'm standing, it might look something like this. That's external. Internal. External. Internal. And then obviously the laying down, it'd be the same thing. Internal. I'm sorry, external. Internal. External. Internal. So that's important. If you're working with a client eventually and you're trying to assess range of motion or certain muscles, you better not flip internal and external. You're going to get a whole different set of muscles, right? And sometimes these things are illusionary, right? So did that answer that question?
Or is there going to be some positions you're going to
Oh, we're getting to those next. We did the easy ones now. Now we're going to get to the hard ones. I love the way you think. Y'all ready to get to the hard ones? So what we know is, again, moving on the board, we can move small piece about the big piece, but we can also move big piece about the small piece. We've already done the one where everything's lined up. External, internal, right? Right external, right internal, right internal, left external, left internal, right external. The last part of class today is when we get our hips outside of anatomical position and we start moving the socket about the hips. Correct me if I'm wrong, Lindsay, but this is probably one of the harder outside of pelvic girdle rotations. This is not easy. However, we have given you a process. Where are you at? Where did you go? How much you had to have moved to have gotten there. Okay? So I'll first start off with doing, I call this the Lord Farquhar from Shrek. So the fact that my knees are flexed doesn't change the fact that my hips are still in anatomical position. True? I'll make sure everybody gets a chance to see. So in other words, bilateral hip flexion, bilateral hip extension, no different. Last class we did this one. Left hip add, right hip add. No different. It's just I can't see my feet anymore. My knees are flexed, but my hips are still in anatomical. That means internal, external, internal, external. It's the same thing from my hips perspective, okay? Now, I'm sure you're like, dude, when in the world are you going to ever do that? Right? Maybe not that. However, it's very common for us to be on one knee. And in this perspective, my left leg is now in the position that I just had, right? Where my knee is flexed, and so I can't see my foot. I can't see maybe something that I've been seeing here. I have to be able to see what's happening either here or there. Okay? So the first thing we're going to do, left hip. What happens when I move the socket? Don't worry about this one. We'll get to this one. left hip, ab, add, so far so bad. Flexion, extension. Maybe if I do something like this, I have external rotation of my left hip. If I do something like this, internal rotation of my left hip. Good? Questions, problems, comments so far? Now let's go to this. Okay. On Friday, we're going to touch about horizontal ab and add, which is a variation of regular ab and adduction, but in the pelvis's transverse plane, not in the pelvis's frontal plane. I'm going to give a whole lecture on it. However, I set you up to hopefully be able to see how my hip can rotate when I move the socket in the frontal, but it's from the long bones transverse. Let me see if I can make some sense of that. We established this is internal and external rotation, yes? So what would happen if femur, lower leg, I'm doing my best with the equipment that I have. See what I'm doing? External, internal. So would it make sense that if I can move the femur about the socket, and this is internal and external, when I move the socket about the femur, and the femur's in this position, this would be internal and external. External, internal. See what I'm getting at? All right, so here's your question. I start here, and I take the socket, and I do this. And this is my new hip position. Don't worry about my trunk. Don't worry about my left leg. I just want you to focus on the right hip and see if you can figure out small piece moves about big piece, long bones perspective. Big piece moves about small piece, long bones perspective. I'm going to give you time because these are the best learning moments when you're just seeing something for the first time and you can try to apply your analytical skills. Talk to a neighbor. Talk to someone in front of you. Make a new friend. Hey, what'd you get? Oh, that's what I got. What'd you get? Oh, gosh, I didn't get that. Let's talk about why we got it. That's how we learn. Start. Finish. Here's my new position. I want you to try to tell me, and I'm giving it to you. I'm telling you, my right hip rotated. I'm giving you that information. I just want to see if you could tell me, was it internal or was it external? Don't answer it out loud. Give it some thought. Does anybody need to see that change from a different perspective? We're good? All right, go. Start to finish. Think of it as I'm being a little teapot. Most people would say, well, your hip didn't move at all. But they're closed-minded. They only see things when they want to see the long bone move. But we've established by now I can still have hip motion by not having to move my femur. I can move my socket about the femur and still have the same change. I'm seeing if you could figure out what was that change. Was it Sam Cooke saying changes in income? Long time coming. Change with joint positions when it comes to You notice nobody got up to do it, huh? It's all right. I'm never gonna make you. Never gonna make you. Hey, guys, we're gonna roll on. Think of this. If you know where you went, you can reverse engineer to figure out how you had to leave. Um, if you sleep in the car and you know you took a nap and you were in Breaux Bridge and you woke up in Florida, you didn't have to literally see it, but you kind of know you went east. So if you can't see the motion, that's okay. Guys, just because we're going to be specialists in human movement doesn't mean we have to really see everything, because the human eyes can only process so many frames per second. You know, I mean, you're watching sport and you see the ball, you see the ball, you see the ball, then all of a sudden it's a blur. Like, whoa, what happened? So sometimes we have to utilize these change in positions. Where was I at? Where did I go? How did I have to move to get there? So how I would look at this, how I would teach this to kind of prove how my right hip had to rotate is, where did I start? Yes, my right hip is flexed. However, it's not rotated anyway from anatomical. Like, it's still, think of it like this, it's still in its transverse anatomical position. True? And then I did this motion. I moved the socket about the ball. Now what I'm going to do is I'm going to look at my new hip position relative to the socket and say, if I had to rotate my hip the way I'm comfortable with, small piece move above the big piece, how would I have to rotate the hip to go back home? Wouldn't I have to internally rotate it to go back to where it started? So therefore I had to externally rotate when I left. This is right hip external rotation, because it gets me to the same place as this. Think about it. When I internally rotated, my lower leg, when my hip was flexed and my knee was flexed, when I internally rotated, my lower leg is nowhere near my midline, right? And when I externally rotated, I see it. So it's very similar. Oh, hey, there you are. Oh, hey, there you're not. Yes? So again, it's hard to see these kind of pelvic girdle rotations that we're about to start talking about, but you can utilize the tools, you could utilize the process and figure it out. And even if it takes you 30 seconds, even if it takes you a minute, the more you do it, the minute will turn into 45, and 45 will turn into 30, and 30 will turn into 15, and 15 will turn into 5. The more you practice anything, the more efficient you'll get at it. But I need you to see how this is the same as this. Try it again. Freeze range. This is the same position change. It's the same position change. Lynn, do you have any input on how you see these?
Yeah, that always tripped me up or something. And then there's that's not even the most complicated one. But the way, I guess if I were, when I first did this class, I was like, okay, we tilted this way, yeah. So what I just did now, seeing it, whenever we tilted this way, I was like, okay, where would my leg go if my upper half was an anatomical right here? My leg would go this way, kick straight out.
into anatomical, if that makes sense. So if it's this way, that's my anatomical. I have to externally rotate, externally rotate to get there.
Yeah.
Yeah.
Yeah. Remember, and we haven't gone over pelvic rotations yet, that's coming soon, but the pelvis is never lost.
Right.
So even when your pelvis moves, you can always say, hey, hip, where are you at? From my pelvis's perspective, and actually in the notes I give you, that's the penguin in the pelvis. Does it kind of look like a penguin? But like your pelvis has a perspective of sight that can help you see how the hip might be rotated.
Yeah.
Oh, look, I'm externally rotated because I see the inside of the leg. Oh, I'm internally rotated because I don't. So if you go the other way, so if Lindsay went here and she took the socket and did this, can you see how my right hip would now be internally rotated? I'd have to externally rotate to line it back up. Yeah.
Internally to do that. So always think about your pelvis as an anatomical. So like I would always just follow it and think, okay, if I want to get to anatomical, I'd have to do this and have to do this to get where I need to go. And like even if you want to do like process of elimination, I know you like to do that.
Yeah.
If you're this way, you're like, okay, I know that this is internal and this is external. No matter where I am, this is internal. So if I'm this way, and I internally rotate, it's not what it is. Like I have to kind of more externally rotate to get more.
Mm-hmm.
Does that?
Yeah.
I guess you could explain it better. Like I'll do that with other joints too. So it's like, if I extend, that's not going to get me where I want it to go.
Yeah.
But if I give
Same
it,
does. Yeah. Yes. Yeah. And again, guys, there's no law that says this stuff has to be easy. But it can be easier if we work at it, just like anything else. Just like anything else. Like anything you've ever done that was challenging, the more you did it, the better you got it. Easier it became. Okay? Well done. All right. Now let's get into the last lesson of the hip, so that way we can do some more socket moving about the ball. In anatomical position, all of our roads are accountable. In anatomical position, I could go sagittal, flexion, and extension. I could go frontal, ab and add, or lateral flexion and extension. We call it ab and add. And I could go internal and external rotation. Three-dimensional motion is complicated, but we're going to try to keep it simple. Having ball and sockets allow us to travel down different interstates that might run in similar directions. Anybody from North Louisiana? North Louisiana, like Opelousas or above? Nobody likes that joke. So we know that there's an interstate in North Louisiana called I-20, right? And it runs the same way as I-10, east and west. But in order to get to I-20, you got to travel up. Like you got to go north in order to go east and west on I-20. So what I want you to imagine is flexion, this general motion that has a combination of rotation and translation. My arms are going up. My arms are going up in both. It's just going up in different planes, right? But once I'm north, that unlocks a new interstate that I could travel on that I didn't have a chance to travel on before. The I-20. This motion, I'm doing it in my shoulders, but it's the exact same as the hips. It's just a heck of a lot easier for me to do this than do that. This motion is called horizontal ab and add. It's a variation of ab and add. But if you think about it, at any one point in our shoulder joint of triaxial, I only have 3 planes and I have 6 motions. You can't have more than that. So if you think about it, down here, My sagittal options, flexion and extension, my frontal options, ab and ad, my transverse options, internal and external. But when I'm here, flexion and extension are not an option. Think about that for a second. My options are ab and ad, internal and external, and now this variation of ab and ad called horizontal ab and ad. It's very similar to ab and ad. Lateral flexion, lateral extension, except it's transverse. Let me show you what I mean with my trusty old Kindle. Let's say we were going to do a circle. I go here, and I go here, and then I want to go back. Okay? Ken abducts frontal plane away from anatomical. But in order for him to get back home, he could either go the exact way he came, or he can take the long way, but he has to adduct. So the short way would just be, if I abducted, Ken can adduct, great, he's home. Or Ken could take the long way and go abduction, horizontal adduction, and then extension. Horizontal ab and ad is regular ab and ad, except you're in the pelvis's or the trunk's transverse plane. Notice I gave it perspective. Watch. Ab, ad. But if I turn the clock like this, I could still go from 6 to 9 and have ab, and then 9 to 6 ad. You see the similarities? My hips are flexed. Still a triaxial ball and socket. I still can move 3 rows, 6 ways of movement. Flexion, extension, internal and external rotation, horizontal abduction, horizontal abduction. Does that make sense? Let me show you how similar they are. Because again, from the femur's perspective, see if I can even do this. It's so much easier with my arms. Let's show you. From my femur's perspective, if I was laying down and I did ab and ad, horizontal ab and ad. It's just a variation, it's a version. It's like cherry Coke is still a version of Coke. Caramel coffee is still a version of coffee. Horizontal ab and ad, giving you the definition, is just like ab and adduction, but instead of the socket's frontal plane, the socket's frontal plane, we're in the socket's transverse plane. And that's another reason why I had to introduce you to perspective. That's one reason why the socket owns 2 perspectives, is so that when we do motions out of sequence, we get to the same place. Left hip flexion, left knee flexion, left hip horizontal ab, left hip horizontal ad. Extension, regular ab, regular ad. Now, we don't have to say regular coffee, it's coffee. The variations have to have the extra stuff in it. Coffee's just coffee. It's the variations. So we don't have to say regular ab and ad. That's ab and ad. But if it's a variation, we have to say horizontal ab, horizontal ab. And it gets me to the same place. Regular ab, horizontal ad extension gets me to the same place. Last question for the day. Right hip. I could have flexion and extension. I could have internal and external. But I can't have regular ab and ad in my hip position because I traveled up and now I can't move on I-10. I can only move on I-20 now that I went north. So what I want you to see before I ask the question is in a kneeling position. It looks like it's moving, and it is. Right hip, horizontal ab. Cool? Right hip, horizontal ad. Cool? Now let's move the socket about the ball and see what that would look like. Unless you understand why I'm explaining perspectives, so many students are going to tell me this is rotation. This is internal or external rotation in my right hip, because all they're going to see is the socket doing this. But if you understand that, no, the internal and external is from the perspective of the long bone, and the flexion, extension, abduction, adduction, and horizontal ab and adduction are from the perspective of the sockets. Here to here, give that some thought. What motion did I just have at my right hip? Don't answer it right away. Give it some thought. Start, finish. Start, finish. And then I come back. What motion is here? What motion is there? Here to there. Oh. I think after today, we're ready to go into pelvic rivers. Give it some thought. I love discussion. Hey, what'd you get? What do you think? From here to here, from there to there, change in position. Where did I start? Where did I go? How must I have to move to get there? Process, process, process. I know darn well y'all don't have what's 845 minus 262. You don't have that math question memorized, but you know the process to figure it out. I'm just applying that to human movement. It's impossible, guys, to memorize every possibility. There's too many movable parts, but we can memorize a process and we can figure out any math question that gets asked about to us. For bonus points, meaning you're going to get it right on the test, which is cool. Tell me what happened to my left hip also. All right, guys, I'm just going to answer it and I'll open it up to follow-up questions. So what I'm doing here, remember last class I said with the pelvis, the right socket is connected to the left socket. The right femur isn't connected to the left femur, but the right socket is connected to the left socket. So when I did this to my sockets, I had right hip horizontal ab, and I had left hip internal rotation. They don't have to do the same things. When I come here, I have right hip horizontal add, and left hip external rotation. And it's all because of the position of my hip. I'm not in the same hip position. This is the same hip position, internal, external, internal, external. But now this one traveled up to North Louisiana and is not on the same interstate. So they can't be the same motions. Does that make sense? They can't be the same motions. They're not on the same roads. I hope today was educational. If y'all need anything, you let me or Lindsay know. Y'all have a great day. We'll see you Friday.